Today we're going to take a look at what monomials are. On the first page here we have a monomial. We're going to explain why it is a monomial. Also have some diagrams here of basically just squares. Think about the formula for an area of a square. It's if the side is x, then the formula would be x squared. So when we have formulas for area and volume, those are also considered monomials. And again, we're going to talk about why that is in just a second. On this page, in this column, we have a list of monomials: negative 1/2 x cubed, x, 100 xyz, 0, and 5x. However, in this column, these are not monomials: 5x to the 1/2, 2x to the 0.1, 9x to the negative 4, and x plus y. I want you to think for a second. You can pause the video if you'd like. What makes a monomial monomial, and why are the ones on the right not monomials? So here we go. This is what separates a monomial from one that isn't. A monomial may contain a constant number. All right. So for example, any constant number, negative 7, 1, 0, even pi is a constant, even though it's a decimal that goes on forever. Any number, okay, that you can think of is a monomial. Okay, a fraction even would work, like 3/4. Those are all monomials. Okay. Another way to explain what a monomial is, it's more concrete, exists more in the real world, like we talked about area or volume, or just a straight number. Any number on the number line is a monomial. Now, a coefficient is a number in front of a variable. And so 3x, for example, would be a monomial. It contains a coefficient, and it leads us to the next thing, variables, okay? So, for example, x is a monomial, y, m, z, all of those are variables. Therefore, they are monomials. Again, they're more concrete. For example, maybe m could be the amount of money in your bank account. That's a monomial. You could put a number next to it, a coefficient, say 3m or whatever. That'd be tripling your bank account. That would be a monomial. Last thing, which might be one of the most important things, is it has to have a whole number exponent. So the exponent has to be a whole number. It can't be anything else. If we look at this previous page, the reason why these first three are not monomials is because this is a fraction, this is a decimal, and that's a negative number. Those are not whole numbers. Remember, whole numbers are 1, 2, 3, 4, 5, 6, 7, 8, so on and so forth. So let's take what a monomial cannot contain. So operators. So for example, so you have x plus 7, and specifically the operators plus and minus. Okay, if you have x plus 7. Those are actually two separate terms. X is one term and 7 is another term. And remember, the prefix mono means one. When you have more than one term, that's not a monomial anymore. Comparisons. All right, so for example, x is less than 7. Now we're getting into an inequality. Yeah, x is a monomial and 7 is a monomial. But when you put the less than sign there, it's comparing two things. It's not a monomial. X equals 3, that's an equation, right? That's also not really a monomial because of that equal sign. 3/x, not a monomial. We'll talk about that later, but basically that becomes x to the negative 1, which is not a whole number exponent. Exponents that are not whole numbers. So negative 3 is in the exponent, 1/2 is in the exponent there, 0.5. None of those are monomials. The exponents have to be whole numbers. And again, that kind of goes back, I always think about area and volume, okay? If it's a formula for area or volume of a cone or sphere, or area of a square, rectangle, triangle, all of those are more concrete, and those are examples of monomials. It's a great way to help yourself remember. Let's take a look at one more set of columns here. So on the left, we have some monomials. Now, you might think, well, what about this coefficient? That's a fraction. Remember, the coefficient can be any number it wants to be. We're worried about the exponent. In this case, it's a whole number, so we know it's a monomial. Here's a number by itself, 900. That's a constant, right? We said those are monomials. And 5y, that contains a coefficient and a variable. It is a monomial. More or less what you're looking for is check the exponent, make sure it's a whole number, and make sure it's a single term. Nothing's being added or subtracted. That leads us to these that are not monomials. This one right here, not a monomial because of the 3/4. That is a fractional exponent. That's not a whole number. X minus y is not a monomial. It's two different terms. X is a monomial and y is a monomial. When you subtract them, they become two monomials, which we'll talk about later. That's called a binomial. 9x to the negative 59, not a monomial because the exponent is a negative number. It's not a whole number. 500 divided by x. Again, if you were to convert that, it would be x 500x to the negative 1. The exponent is negative, and therefore it's not a monomial. Another way to look at it is if you ever have a variable in the denominator, that is not a monomial. It's actually called rational, or a rational function. We'll talk about that later. X over y, definitely not a monomial. Again, you have a variable in the denominator. And x to the negative 3.01, definitely not, because the exponent is negative and it's also a decimal. Remember, it has to be a whole number. Let's go ahead and test our knowledge now. Is the following a monomial? 5 plus x squared. Well, right off the bat, you should be able to see that something's up here with this plus sign, right? We can't have that, so no. It is not a monomial because it's two different expressions. Next example, is 0 a monomial? Well, you might think yes, you might think no. Let's see. Well, it's a constant number, right? And we said a monomial can be a constant number. So the answer is yes, it is indeed a monomial. All right, is the following a monomial? X to the pi. Well, let's think about this for a second. Pi is a decimal that goes on forever. We said the exponent has to be a whole number. The exponent is not a whole number, so the answer is no. It is not a monomial. Remember, now if this was a 2, yeah, of course, x squared would be a monomial. Again, that goes back to thinking about the area, formula for an area of a shape. X squared, for example, would be the area of a square with side lengths x. That would be a monomial. But because this is a decimal, it's not a monomial. All right, pi x squared, is that a monomial? Well, let's think for a second. What is this? This is a coefficient, right? Coefficient can be any number, okay? The coefficient doesn't have to be a whole number. It can be a decimal, in this case it is, and we're good, okay? What we're focused on is the exponent. Is that a whole number? Yes. Okay, and the variable can be whatever it wants, and so actually, yes, this is a monomial. Has a whole number exponent, and the coefficient pretty much can be whatever it wants to be. All right, how about this one? We have x squared y cubed z to the 100. Are we good here? Well, it looks like we have multiple terms, but it's actually one single term, okay? If you have a bunch of variables next to each other, as long as there's no plus or minus between, you're good because it's one single term. And remember, mono means one. And let's take a look at the exponents. They're all whole numbers. So actually, yes, this is a monomial. It's a monomial because all the exponents are whole numbers and it's one single term. If you have any questions about that, let me know. I'd be happy to explain that further. Let's take a look at the next example. All right, so we have a variable here. Is this a monomial? And we have a coefficient. Now the coefficient is not a rational number, but it's still a constant number. Remember, the coefficient really can be whatever it wants to be. It doesn't affect whether or not something's a monomial. We just want to make sure the exponent is not a decimal or a negative number. And in this case, there is no exponent, so it can't be a decimal or a negative number. So we're good. So in fact, yes, this is a monomial. It passes the test for that. Let's take a look at one more. Let's switch it. Let's take the square root of 7 and make it the exponent. Now we have something different because the exponent now is going to be what? It's not going to be a whole number, right? It's going to be a decimal. In fact, I think it's a decimal that goes on forever. But nevertheless, it's an exponent. It's going to become a decimal, which is not a whole number, and therefore this is not a monomial. So that's it for this lesson. This is just figuring out what a monomial is. We'll be using this a lot in the next many lessons to come. Very important fundamental concept. If you have any other questions about this, let me know.